Good afternoon, everybody. So in the last lecture, we have to be study the amplifier thing. The amplifier, what do you mean by amplifier? Which type of the amplifier used for the application of different audio as well as other type of the application. See, amplifier indicate that whatever the signal applied across your input, that should be amplified. This amplified means in a increased level, right? This is nothing but amplifier, right? We have seen that now. We have already seen the class B amplifier. We have revised this point, and we just compare the class B amplifier with respect to the class A amplifier, right? So see, class A amplifier is the amplifier which should be designed for the purpose of working on with respect to the full 360-degree half cycle, right? So it is the working means class A amplifier working with respect to 0 degree to the 360-degree. It indicates the full half cycle, right? Sorry, full 360-degree cycle. So that what happened, the whatever the transistor used in that configuration, that should be used fully, and that's why it does not turn off at all, right? This is the mainly disadvantages of class A amplifier. So that's why it have less efficiency. So solution for that, we have to be design the another type of the amplifier, that is class B type of the amplifier. See, in earlier cases we have seen that only one transistor is used. That transistor should be working in a 360-degree half cycle. So that's why burden on that transistor is happen with respect to class A type of the configuration. So that's why we have to be design the another type of the amplifier which give the solution for the burden of the particular 360-degree working of your transistor. So that's why we have to be use the two transistor which should be used in a alternating 180-degree half cycle. So that's why what happened, no burden on one of the transistors. So that's why the working level of your class B amplifier improve. That's why we have to be design the class B type of the amplifier. See, this is the diagram of the class B type of the amplifier. See, any type of amplifier, it indicate that we have applied the signal, it should be sine wave. Sine wave indicate that your whatever the signal coming with respect to your Why is that? Also the sine wave, right? So sine wave, that signal which should be applied across your input. See, there are two transistors. This is the upper transistor, this is the lower transistor. Whatever the transistor used here, that are exactly opposite. What it indicates, that consider that one of the transistor as a NPN, or there is PNP. Why it is different? Because see, AC have two half cycle, that is positive and negative half cycle. So one of the transistor means consider as a upper transistor should be working in a positive half cycle, lower transistor should be working in a low negative half cycle. So that's why we have to use the two type of transistor. So that see, so that's why we have biased the transistor such a way that upper transistor should be working in a positive half cycle, lower transistor should be working in a negative half cycle. Okay, so we have applied the signal, that is AC signal applied to the amplifier during the first positive half cycle. Upper transistor should be turned on. So what happen? It should provide the input. Whatever the input provided, it should be amplify that input. So we got the amplified output across its output, right? See, but see, whatever the signal coming across you, it is a only 180 degree. Why it is 180 degree? Because we have tuned indicate that biased transistor such a way that it should be worked in 180 degree half cycle. It indicates that upper transistor should be worked from 0 to 180 degree, and lower should be worked above 180 to the 360 degree, right? So that's why alternating half cycle they have to be worked. So that's why we got the output in only one half cycle with respect to this one transistor, right? This is the thing with respect to the output of your transistor. So what is this? See, this is the Q point diagram of the particular transistor. What it indicates, that your transistor is biased, means Q point of your transistor is here. So that's what happened. So that's why what happened, whatever the input applied, only one transistor give half part. So that's why we got the output as here in this way. Means we apply this full half cycle sine wave, and we got the output only positive or negative half cycle. Why it is? Because we have tuned the transistor such a way, that's why it should be working now only positive or negative half cycle only. Okay, class B amplifier चे जनरलाइज थिंग लक्षात आले का? प्लीज रिप्लाय द्या, काय याच्यातलं लक्षात आलं असेल तर विचारा. आणखीन डिटेल आपण पाहणार आहोत. जनरलाइज थिंग म्हणजे क्लास ए आणि क्लास बी मधला डिफरन्स लक्षात आलाय का? एवढंच फक्त याच्यातनं अपेक्षित आहे, पुढे डिटेल मी सांगणार आहे. धनश्री दळवे लक्षात आलाय का? अंकुल की तुमच्या लक्षात आलाय का? जस्ट इंट्रोडक्टरी थिंग. ओके, पण डिटेल पार्ट पाहूया. See, we have seen that with respect to the class B amplifier. See, we know that there is a many more problem coming with respect to the class amplifier. With respect to the efficiency, there is a very less efficiency, that is near about 20 to 30% of the efficiency of class A amplifier. And another thing with respect to class amplifier is that it should be, means whatever the transistor used in that configuration, that should be worked in a only one half cycle, that is a either a positive or negative half cycle. So that's why whatever the burden coming, means whatever the burden coming with respect to one transistor in case of class A, that should be overcome by this class B type of the amplifier. For the purpose of amplification, we have to be use either any of the devices such as transistor, field effect transistor, or insulated gate bipolar transistor. These are the device. Basically, these are the transistor, but the sum of the function, that are the difference. Some are voltage control, some of the current control, right? So any of the devices we have to be used for the purpose of the class B amplifier. See, we have seen that we have to be use the two transistor here, because in case of class B, we have to be done the burden. See, in case of class A, there is a burden on one of the transistor. To overcome that burden, we have to be done the another type of the amplifier, class B amplifier. In that amplifier, we have to be use the two transistors, right? So each transistor should be working in a 180 degree half cycle. So that's why one transistor should be act as a push. See, concept of push and pull, I am telling you. One should be act as a push, other should be pulled. So one transistor should be, see, there are two half cycle with respect to whatever the AC input apply. So during the first half cycle, one transistor should be on, so it should be act as a push, and other should be pull, it should be turn off. So that's why it should be act as a push and pull configuration. So that's why only one transistor should be on at one time, right? So we have seen that during the positive cycle, upper transistor should be on. During negative, this transistor should be on. This configuration is called as push-pull type of the configuration. So only one should be on. That's why it should be considered as a push and the pull type of the configuration at a time. Okay. See, in a class B amplifier, there is no DC base bias. What it indicate that DC base bias indicate that we doesn't apply any DC voltage with respect to your transistor. So what happened? We have not applying any DC voltage. It indicate that question indicate that minimum voltage or current applied across it is a zero. Means question indicate that minimum current which should be applied was to work in a particular condition. But in this case, we doesn't apply any DC current with respect to the devices. So here, so no DC is applied, so DC power whatever coming across your output, that should be less, right? So that is the main thing with respect to this type of the configuration. Why it is? See, we have discussing the amplifier, right? So amplifier indicate that we have applying the input, whatever the input applied, that should be amplified. But one of the condition with respect to amplifier is that we must have to be apply the AC signal, right? We must have to be apply the AC signal. If we have apply any DC signal, so that's why it should also amplify, but the effect of it noise is added. So that's why in this case we doesn't amplify the AC signal, because DC signal. Why it is? Because in this case DC power is small. So here is DC power is small, so it indicate that here is no noise is added. So that's why no noise indicate that this type of the configuration how the efficiency is more, because no noise means no other things should be added. So it should give whatever the input signal amplified, that should be only amplified, no other mixed part is added with it, right? So that's why in this case efficiency of this type of the configuration is more. The reason when it is only thing is that here we doesn't apply any signal, so that's why DC power which should be added, that should be very less, so no noise is coming. So that's why it should be more efficiency given by this type of the amplifier. So one of the important condition with respect to that, it also means it should give the higher efficiency, but however the price paid for the improvement in the efficiency is the linearity of the switching device. What it indicate that I'm already told you, when we have not applying any DC signal with respect to this type of the configuration, what it indicate that we doesn't apply DC signal, it indicate that noise is not added, so efficiency is added. So efficiency is added, but linearity means what? See, whatever the input signal applied, consider as a sine wave, right? So whatever the output coming, it should not be sine wave. Sometimes why it is happen? Because when we have to be increasing the efficiency, another effect on this type of the configuration is that whatever the input applied, that should not be as it is output. Why it is? Because there should be the effect of it means we have to be applied the not applying any DC signal. The effect of it, there should be whatever the output coming, they are not linear. Means input जसं apply केले ना त्याच्या respect to output मिळत नाही, ते as it is मिळत नाही. म्हणजे there should be effect of the efficiency, increasing efficiency, but there should be reduction in linearity. Linearity indicate that what replica of input with respect to replica indicate that if we have applied the sine wave, we got the output that should be some of the distorted sine wave, right? That is the thing when we have to use the class B type of the amplifier, right? So one of the important condition with respect to class B amplifier, crossover distortion, one of the effect which should be coming with respect to this class B type of the amplifier, that is a crossover distortion. What it indicate that? See, crossover indicate that when we have to be transition from zero to another, means lowest towards the higher, or the 180 towards the 360, right? In that portion, what happens? See in the diagram. See, this is called as the concept of crossover distortion. I'm telling you lastly. See, initially we have discussed the point. See, whatever the thing happened with respect to class B amplifier, there are two transistor we should be worked with respect to the class B amplifier. See, two transistor indicate that one of the transistors should be worked in a positive cycle, other should be worked in a negative cycle, right? This will be upper. Why it is? Because we have to done the such a way arrangement that which causes there should not be burden on one of the transistors. So that's why we have biased transistors such a way that which causes one of the transistors should be worked in a positive half cycle, another transistor should be worked in a negative half cycle, right? So what happens, one of the transistors should be turned on, other should be turned off at any time, right? The condition coming with respect to this, only one transistor should be on, it indicates that other transistor should be turned off, right? When the input signal goes negative, means with respect to C, we have to be considered as a positive input is applied across you. So in that case, positive only one transistor, that is positive signal applied transistor, positive biased transistor should be worked at that time. Other transistor indicate that negative biased transistor that should be turned off, right? So another cases when negative half cycle is coming, in that case, when negative biased transistor means another transistor should be on, positive transistor biased transistor should be turn off, right? This should be cycle happen again and again. Why it is? Because whatever the signal applied, that should be sine wave, and sine will indicate that it have to half cycle. So only one side half cycle, one transistor is worked and other transistor is not worked. This will be happen in case of class B type of the amplifier. See, then we can see that each transistor device of the class B amplifier only conducts through 1/2 or 180 degree of the output waveform, right? In strict term, what it indicates that I already told you the intention. See, intention of the class B amplifier design is that the reduction of the burden in the transistor working in all over 360 degree time, right? So that's why we have designed means biasing the transistor, either your PNP or NPN, because two transistor must be required here, right? So we have biasing the transistor which should be worked only 180 degree half cycle, only 180 degree, either it is a positive or negative half cycle. So that's why what happened, we have applying the any signal, it should be means any of the transistor, either your positive half cycle means transistor or negative half cycle working transistor, they have to be worked only 180 degree, means we have designing, means we are applying the voltage such a way that it should be worked only in a 180 degree half cycle. So that's why there should be alternating transistor work at a particular full half cycle. This should be happening in case of class B type of the amplifier, right? See, to how here, see, but as the output stage has devices for the both halves of the signal waveform, the two halves are the combined together to produce the full linear output waveform. What it indicates that, see, when we have applied the signal, right, we know that we have applied the signal that is positive and negative half cycle. See, whatever the output, see, we doesn't require only positive or negative half cycle. Why it is? जर आपण पॉझिटिव्ह निगेटिव्ह हाफ सायकल घेतलं, ऍक्च्युली अँप्लिफायर काय इंडिकेट करता, तुम्ही जे बोलताय, समजा तुम्ही जे बोलताय ते अँप्लिफाय करायचंय. जर समजा पॉझिटिव्ह हाफ सायकल घेतलं, तेवढ्यामध्ये माझं जे बोलणं ते अर्धच राहणार आहे, लक्षात घ्या. In case of we consider as a one full half cycle is my talking, right? So if we have to be use either positive or negative half cycle, it should some part remaining, right? So that's why what we have to do, we have to be connecting positive as well as negative half cycle, and in that case whatever the you are talking or whatever the thing with respect to your amplifier, that should be completed. This will be happen to connecting positive as well as negative half of the your amplifier session. Okay, see, why we have to be used the push pull type of the design here, means why we have to be used the transistor, means either you one of the transistor user as a PNP, other user as a NPN. The reason behind it is that we already told you the reason behind it is, see, if we have to be, if consider as a, if we have to be use the NPN type of transistor for the working of the two half cycle, right? So it is not possible. Why it is? Because see, NPN transistor we have applying the biasing voltage such a way that which should causes it should be work only negative or positive half cycle only, right? So that's why other positive or negative half cycle going outside, or it is not coming with respect to your output. So that's why we have to be design the transistor, two transistors such a way that which should be worked in one half cycle, other should be worked on another half cycle. So that's why here one transistor should be worked in a 50 per one transistor should be used at 50%, that is positive half cycle, other should be worked in other 50%, that is a positive or negative half cycle, right? So see, in case of class A amplifier, whatever the push-pull design of amplifier is obviously more efficient than class A amplifier at about 50%. But the problem with the class B amplifier design is that it can create distortion. See, we have seen that class A type of amplifier. See, when we have to be design another type of amplifier that is nothing but a class B amplifier, it overcomes some of the problem of the class A amplifier, right? Means why we have to be design the class B type of the amplifier. The reason behind it is that the class A amplifier, there should be use of the one transistor, that is one transistor used for the total 360-degree, right? So burden on the transistor, so it should be damaged within some days, right? This will be happening in case of class A amplifier. And another thing, efficiency, whatever the output means, output divided by input ratio, that is the less in case of class A type of the amplifier. But due to that, we have to be design the class B type of the amplifier, but means it has some of the more effective than that of class A, but some of the problem coming when we have to use the class B type of the amplifier. See, in case of class B amplifier, what we have to do? In case of class B amplifier, we have to be use two type of the transistor. We should be in the alternating half cycle, that is a 180-180-degree half cycle, either your positive or negative half cycle. But when we have to be use this in, we know that transistor, it should be constructed from the silicon or the germanium, right? So due to the use of that portion from 0 to 0.7 volt, see 0 to 0.7 volt or the minus 0 to 0.7 or another thing 0 to minus 0.7, right? In that portion, what happened? There should not be any working of the transistor. This is nothing but a crossover. Crossover indicate that, see, this is the factor, means consider as a this voltage, this to the this indicate that 0.7 voltage. During that portion, transistor is not worked, right? This will be happen. Another thing, when it should be after all 0.7, it should be worked here. Again, it should be coming here, right? After all, coming across here during this period also, means negative, means 0 to minus 0.7 volt. In that portion also, another transistor is not worked, right? So what happened? See, this is the diagram. This diagram indicate that crossover indicate that high to low. See, high to low transistor or low to high transition. During that period, there should not be work of any transistor. So that's why this distortion is coming. Means this part is not coming with respect to output. That is the biggest disadvantages of the class B type of the configuration. This type of the distortion is called as crossover distortion. The reason behind it is it should be crossover indicate that the transition from your, this is a high to the low, this is a high to the low or the low to the high transition. During that, means crossover distortion indicate that during the phase of the high to the low or low to the high transistor, there should not be work of any transistor with respect to us. So that's why what happened, there should not be output coming with respect to this portion. This is called as crossover distortion. This is the one of the problem which should be coming with respect to the class B type of the amplifier, right? Class B type of the amplifier लक्षात आलाय का? Please reply. का प्रॉब्लेम असला तर विचारा. Please reply लवकर. प्रत्यमाने लक्षात आलंय का तुमच्या?
Yes, sir.
ओके. धनश्री दळवे, तुमच्या लक्षात आलंय का?
Yes, sir.
Okay. This is the part, revised part. We have to start the another session, that is a class AB type of amplifier. See, before seeing this type of the amplifier, whatever thing means introductory thing with which respect to the already thing, class A, class B, we have just discussed introductory thing. We know that there is a class A amplifier which we have to be used when we have to be seen the amplifier. In that case, the problem, see, only we have to be seen the problem with respect to particular configuration. When we have to use the class A type of the amplifier, the reason we have not preferred the class amplifier is that there is a use of the one transistor that should be working on a fully 360-degree half cycle. So that's a burden on it. So that's why there should be less efficiency with respect to class A type of the amplifier, right? Then we have to be see the class B type of amplifier. To overcome the problem we should be coming with respect to class A amplifier, we have to use the class B type of the amplifier. In that amplifier, what we have to do, we have to be done the two transistor, means we have to be use the two transistor, we should be worked in alternating half cycle. So that's why there should be burden of the transistor, means burden of the full 360-degree working with respect to your class A is coming with is less with respect to the class B type of the amplifier. So that's why here is no burden on the particular working of the class B amplifier. So what happen, alternating half cycle, there should be one transistor should be worked, but we know that transistor is constructed from either your silicon or germanium. So in that case there should be one problem coming, that is crossover distortion. Crossover distortion, what it indicate that when transition from your low to the high or high to the low, there should not be any transistor should be worked, because it have its cutoff voltage, right? It should be 0.7 or it should be 0.7 or 0.3. See, in case of silicon it is a 0.7, or in case of germanium it is a 0.3, right? During that portion what happened, no transistor should be worked, so that's why no output is coming with respect to your output, right? So what happened, due to that no output, so it should be part as like a distortion, right? This will be the problem with respect to the class B type of amplifier. See, when we have to be design, म्हणजे आपण जे स्टडी करतोय ना, सुरुवात केली आपण क्लास ए पासून बी पासून, म्हणजे ऍक्च्युअली डिझाईन करत असताना कुठलीही थिंग लक्षात घ्या, प्रॉब्लेम. सी, प्रॉब्लेम इज इम्पॉर्टंट, बिकॉज प्रॉब्लेम जर आला नाही तर पुढचं काहीच होणार नाही, लक्षात घ्या. इन केस ऑफ क्लास ए देयर इज अ प्रॉब्लेम, after all we design the class B. Class B also some of the problems, that's why we also divided decided another type of the amplifier, that is class B type of the amplifier. This type of the amplifier overcome or all of the problem which should be coming with respect to the class B amplifier. See, the problem coming with respect to class B amplifier is not there are no many problems with respect to class B amplifier, because efficiency of the class amplifier, that is a good, right? That is a good, but the problem is coming, it is a distortion. This crossover distortion is problem coming with respect to the class B type of the amplifier. So so what we have to do to overcome that problem, we have to be arranged such a way that during that portion, see, during that portion indicate that crossover portion, we are applying the small bias voltage. See, we are applying the small, I just discussed the generalized thing. We are applying the small bias voltage, which causes when crossover is coming. Crossover indicate that your high to the low or low to the high transistor, in that portion also, some of the output is coming with respect to your devices. So we have to be problem of the crossover distortion, that should be overcome by the applying small bias voltage to the device, right? This should be done in case of class AB type of the amplifier, right? So class C, we just start the why the name is class AB amplifier. C, it should be used for the purpose of it takes the positive thing of the class A and the positive things of the class B. Means class AB type of the amplifier is the amplifier which should be combination of class A and class B. It should be taking the positive thing of the class A and positive thing of the class B, and eliminate bad thing of the A, class A and class B, right? That's why it is called as class AB type of the amplifier. See, the AB classification of the amplifier is currently one of the most common used type of the audio power amplifier. See, we know that when we have to be design the audio power amplifier, I will tell you the example with respect to mobile telephone. जस्ट रिलेटेड म्हणून सांगतो, लक्षात घ्या. तुम्ही समजा बोलताय मोबाईलवर, समजा कॉलवर बोलत असताना, सी, वन ऑफ द इम्पॉर्टंट थिंग सांगतो, ज्यावेळेस तुम्ही बोलत असताना दोन थिंग असतात, आयदर युअर व्हॉइस अँड अदर इज डेटा. डेटाला थोडं डिस्टर्शन, म्हणजे काही काळ जर डाउनलोडिंग मध्ये राहिलं काही इफेक्ट होत नाही, पण व्हॉइसला जर डिस्टर्शन आलं, म्हणजे तुम्ही जर व्हॉइस कॉल चालू असताना समजा एक 2-3 सेकंद किंवा 4-5 सेकंद कॉल बंद राहत, तर तुम्ही बोलताय ते पलीकडे जाणार नाही, म्हणजे व्हॉइसला जास्त. सी, इन केस ऑफ मोबाईल कम्युनिकेशन, व्हॉइस हॅव मोर प्रायोरिटी देन दॅट ऑफ युअर डेटा, राईट? हे रिलेटेड म्हणून सांगतो. ऍक्च्युली हे कशामुळे सांगायला लागलोय की पहा, वन ऑफ द मोस्ट कॉमन यूज्ड टाइप ऑफ ऑडिओ पॉवर म्हणजे क्लास ए बी ऑडिओ पॉवर साठी काय यूज केलं जातं. द रिझन बेंड इट इज सी वेन ज्यावेळेस आपण क्लास ए बी यूज करतो ना त्यामध्ये काय होतं की ऑडिओ सिग्नल जे आहेत ते कमीत कमी तुमच्या आउटपुटला लॉस होते कारण व्हॉइस कम्युनिकेशन साठी तेच पाहिजे. लक्षात घ्या. जस्ट रिलेटेड आलं म्हणून सांगतो. व्हॉइस कम्युनिकेशन तू बोलत असताना काही पार्टी एलिमेंट झाला तर समोरच्याला काही कळणार नाही पण डेटा डाउनलोड करत असताना काही वेळ तो म्हणजे चालूच झाला नाही डेटा तर काही फरक पडत नाही एवढं थोडं वेळानं होईल. लक्षात घ्या. राईट. सो दॅट्स वाय व्हॉट वी हॅव टू बी टेलिंग क्लास ए बी इंडिकेट दॅट it indicate that we have designed the transistor such a way that eliminate the crossover distortion. Crossover distortion indicate that it doesn't got any voice or anything with respect to this type of the configuration. Actually, it is a amplifier. Amplifier indicate that voice. It also amplify the voice. Okay. See, so class AB amplifier designed in such a way that it should be worked in a such a way that which eliminate the crossover distortion coming with respect to the output or whatever the effect coming with respect to the plus crossover distortion that should be eliminated. So see, except that both devices are allowed to conduct. See, in case of class A or class B type of the, in case of class A, whole half cycle means during the both half cycle, that is positive as well as negative half cycle, there should be worked of the one transistor. In case of class B, only 180-degree one transistor should be worked, right? But in this case, what happened? Whatever the transistor used across here, this should be worked see only half cycle, but during this crossover period it should also work a small time, right? Means during the crossover period it should be means whatever the part that should be going outside means that should be distorted. In that period also your transistor should be worked. Means we have designing the transistor configuration of the class AB amplifier such a way that it should not be worked either your 180-degree or full 360-degree. It should be worked greater than 180 and less than 360-degree, right? So what happened? The problem coming with respect to your amplifier is that crossover indicate that it should be during the period from 0 to some or 180 to some negative, right? In that period there should not be work of the any transistor. So during that period this transistor should be worked, right? Means we have designed the transistor such a way that it should not be worked only 180-degree, it should be worked more than only 180-degree. So problem coming with respect to 180-degree voltage or the 0 degrees, right? See, problem is coming with respect to up to the 0-degree or the greater than the 180-degree, right? This problem should be overcome by whatever the transistor used, that should be used greater than 180. So up to this portion, right? Up to this portion indicate that this is not coming, means whatever the fluctuation or whatever the distortion coming, that is not coming because of there should be working of your transistor. Means no transistor should be off. Means we have designing the or biasing the transistor such a way that it should be worked during the portion of the crossover distortion part also, right? So that's why there should not be crossover distortion coming with respect to the amplifier. The two transistors have very small bias. I already told you the two transistors have very small bias voltage. Bias voltage means what? We are applying the voltage with respect to transistor in the due to the application of the particular voltage, means DC voltage with respect to the transistor. What happened during the crossover period? During the crossover period, it should typically that period is nothing but up to the 5 to 10% of the portion. See, this is the portion, right? This is the smallest portion, right? During that portion we have applying the voltage. That voltage is called as bias voltage. Means during bias voltage indicate that during that portion, means crossover portion, your transistor should be worked, right? So transistors should be worked indicate that they should not be turned off. So that's why they should not be turned off indicate that whatever the signal which should be distorted in case of class B, that should not be distorted. So that's why in that case there should not be distortion coming. So then the conducting device either bipolar or FET will be on. See, I'm telling you we know that in case of class B, during that period no transistor should be on, right? But we have applying the biasing voltage. Biasing indicate that we directly applying the voltage to particular output part of your transistor. So that's why during that portion output is coming across your devices, either your 0 to some portion, 0 to some portion, or the 180 to some portion, means either your positive or negative is changing. In that portion also we have the output. So that's why there should not be chances of the crossover. This will be happen in case of class B AB type of the configuration. See, then the conducting device, either bipolar or FET, will be on for more than one half cycle, but much less than one full half cycle. And tell you what happened. I already told you, we know that class A is full 360 degree, then class B 180 degree, and class AB, which should be greater than 180 degree but less than 360. It indicates that. Why it is? Because when it should be worked on 180 degree, it have problem of the crossover distortion. Greater than 180, what it indicates that there should not be chances of crossover, because during the crossover period it should be turned on. So that's why we use any devices such as transistor or FET, which should be worked one full half cycle and the some part of the other half cycle. So during that portion there should not be chances of the distortion, right? This will be happen in case of the class AB type of the amplifier, right? So we know that in case of class B, it should be worked with respect to the 180 degree. Class A, it should be 360 degree. So in between indicate that greater than 180 and less than 360, that is the configuration applied across your class AB type of the configuration, right? So in other words, the conduction angle of the class AB amplifier is somewhere between 180 and 360 degree. I'm already told you why it is. I'm telling you the reason behind it is that when we have to be transistor biased in such a way that it causes the two things indicate that two crossover distortion that should be related to the 0 degree or greater than 180 to the 180 degree centigrade, right? So in that case what happened, we have applying the voltage, means we have turn on the transistor. So that's why what happen, there is any of the transistor should be on. So that's why no turn off your transistor, so output is coming across your devices, so no distortion is coming. This will be happen with respect to the class AB type of the amplifier. This will be happen only, the reason that it is class AB type of the amplifier should be worked greater than 180 and less than 360 degree only. See, this is the class AB type of the amplifier. See, this is the class AB type of the amplifier. It is same as like as class B amplifier. I'm telling as like as, it is not same, but see, same as like as class B amplifier, but only change is that we have applied some bias voltage. That's why we have bias indicate that we have applied some voltage with respect to a transistor. That's why we have used the diode here. See, one of the diode, we have uses the diode. See, there are actually two diode. One diode should be working in a positive half cycle, other should be working in a negative half cycle. Why it is? Because there are two crossover distortion. This is happen with respect to positive half cycle. This is happen due to the negative half cycle, right? So when we have to use the one diode, in that case only positive crossover should be reduced and negative should be remaining. So that's why we have to be use the two diode, which causes it should be biased or work during the positive as well as negative half cycle, which we provide the positive during the portion of distortion. It should be provided to the transistor. See, this is the diagram, this Q point diagram of the class AB type of the amplifier. This is called as Q point diagram. This is called as Q point diagram of the transistor. So during that diagram, there should be Q point is here. Q point is here. So the transistor is working above this level, right? Above this level, right? Above this level, and below also some portion. What indicate that it also works some of the negative portion also. So one full positive half cycle and some part of negative half cycle, there should be bias portion of class AB type of the amplifier. So due to the use of class AB amplifier, whatever the transistor we have designed, that should be worked in between 180 and 360 degree cycle. Okay. क्लास AB बद्दल काय शंका आहेत का, विचारा. प्लीज विचारा, काय प्रॉब्लेम आहे का, काय लक्षात आलं नाही काय, काय याच्याबद्दल विचारायचंय. लक्षात आलंय? येस ऑर नो एवढं तर सांगा, किंवा जर काय प्रॉब्लेम असेल तर सांगा जावा. लक्षात तर येते ना? प्लीज रिप्लाय. पल्लवी कोकरे लक्षात येते का तुमच्या? धनश्री दळवे, प्लीज रिप्लाय द्या.
येस सर.
ओके. डायग्राम कडे बघून तुम्हाला काय वाटतं एवढं सांगा मला. आता तुमच्याकडे आन्सर हवेत. या डायग्राम मध्ये बघून कम्पेअर टू द ऑल अदर क्लास ए आणि क्लास बी, व्हॉट विल बी द चेंज अँड व्हाय इट इज डन. जर तुम्हाला मी आता सांगितलेलं समजलं असेल तर याचा आन्सर देता येईल. याचा अर्थ असा होईल की तुम्हाला काहीतरी समजते. व्हॉट विल बी द चेंज विथ रिस्पेक्ट टू अर्लियर डायग्राम अँड दिस डायग्राम, व्हाय इट इज डन. यापैकी कुठल्या एका क्वेश्चनचा आन्सर द्या. प्रियंका पवार सांगा. प्रियंका पवार सांगा. कोण सांगेल तुमच्यापैकी सांगा. थिओरॉटिकली क्वेश्चन याच्यावर विचारले जातात, म्हणजे एक्झाम साठी क्वेश्चन विचारत असता ऑपरेटिंग पॉईंट वर, म्हणजे क्लास ए त्याच्यावर 1 मार्कला क्वेश्चन असं विचारलं जातं, ऑपरेटिंग एरिया ऑफ द क्लास ए एम्प्लिफायर, ऑपरेटिंग एरिया ऑफ द क्लास बी, क्लास ए बी सगळं विचारलं जाऊ शकतं. ए साठी तो 360 डिग्री आहे, बी साठी तो 180 आहे, क्लास ए बी साठी ग्रेटर दॅन 180 अँड लेस दॅन 360. ओके. आणि आणखीन असा क्वेश्चन याच्यावर विचारला जातो, ट्रान्झिस्टर सिंगल का यूज केले जातात क्लास ए मध्ये, क्लास बी मध्ये 2 का यूज केले जातात, क्लास ए बी मध्ये 2 विथ डायोड का यूज केले जातात, असे पण क्वेश्चन विचारले जातात. प्लीज रिप्लाय द्या. त्याच्यावर काय चेंज आहे आधीच्या डायग्राम मध्ये याच्यामध्ये. अंकल की तुम्ही सांगताय? लक्षात आलं नाही का? रिपीट करू का सांगा. रिप्लाय द्या. अंकल की
येस सर.
लक्षात आलं नाही का?
नो सर.
ओके, सांगायचं ना असं. सांगतो मी रिपीट एकदा. एक लक्षात घ्या. सी वी हॅव सीन द क्लास ए बी टाइप ऑफ द एम्प्लिफायर, राईट. सो क्लास ए आणि क्लास बी समजलेत का? क्लास ए आणि क्लास बी समजलेत का सांगा.
येस सर.
Okay. I just give introduction with respect to the class A type of the amplifier. Class A amplifier is the amplifier which should be worked in a full 360 degree half cycle. Means whatever the transistor used in a class A type of the amplifier, it should be used or worked in a full 360 degree half cycle. So effect of it. So effect of it is that efficiency is reduced and burden on your transistor. This will be happen in case of class A. Probably we have seen the class B type of the amplifier. See, class B type of the amplifier is overcome the burden whatever coming with respect to the class A amplifier, right? So in that case we have to use the 2 transistor. One transistor should be worked in a 180 degree half cycle, other should be used another 180 degree half cycle. But the solution means due to earlier solution means it should be worked in a 360. So reducing the period of the working of your transistor, we have designing the class B. But see, when we have to be design the class B, one of the problem coming with respect to class B is that we have to use the class B. It causes there should be crossover distortion should be coming. It indicates that noise should be coming with respect to the class B type of the amplifier. So why that noise is coming? See, we have to use the transistor. That transistor should be constructed from your silicon or germanium. Basically, silicon and germanium is nothing but a semiconductor. It have its own property, right? So we have to use the silicon. It indicates that during the portion of the 0.7 indicate that for the silicon, 0.3 indicate that for germanium. It have called as conducting voltage, or it is called as cut-in voltage, right? So during that portion, in case of class B amplifier, that transistor should not be worked. So that's why fluctuation of the output means during that portion no output is coming, right? Either your 0 to increasing level, 0 to increasing level means this portion there is not output, or 1 means low to the high transition or high to the low transition there is not any output, right? So there is not any output, so it indicates that noise should be coming with respect to the crossover portion, right? So that's why to eliminate that noise we have to be designing the class AB type of the amplifier. See, I'm discuss the class AB type of the amplifier. So class AB name indicate that it is the basically combination of the class A type of the amplifier and the class B type of the amplifier. So in that case, we have to use the positive thing of the class A and the positive thing of the class B, which should be used in case of class A B type of the amplifier. We know that class A type of the amplifier. काय problem आहे का? See, in case of class A amplifier, it should be worked in a full 360 degree, and class B work should be 180 degree. So combination of it indicate that we have problem. See, we have problem with respect to only two cases, that is 0 to some degree and 180 to negative some degree, right? We have problem in between 0 to this and 180 to some degree. It indicates that we have problem with respect to greater than, we have requirement of the greater than output, which should be greater than 180 degree only, means your output should be fluctuate from your 0 degree to the 180 degrees related thing. So we are designing the transistor such a way that which should be worked during the period of the 0 to greater than 180 degree. So that's why we have designing the other configuration, that is class AB type of the configuration. This is the configuration. See, this is the configuration. In this configuration, we have to be use the transistor which should be worked greater than 180 degree and less than 360 degree. So we have to be problem coming with respect to class AB type of the amplifier is during the period of the more than 0 to some degree, 0 to consider as a 10 degree, 180 to 190 degree, right? 190 degree, that is positive change and the negative change, right? So to overcome that problem, we have to be design the transistor such a way that it should be worked on that period, means it should be worked on that period. It indicates that there should be problem is not coming with respect to crossover, that is 0 to some positive or 182 degree to some negative, right? In that period also your transistor should be worked. So that's why we are applying the sum of the biasing voltage. Biasing voltage indicate that we are applying the voltage. This voltage, either your transistor positive half cycle or negative half cycle should be worked. In that case, whatever the signal applied here, that should be provided to the through the transistor. So what happened? Consider as a positive half cycle is coming across your output. So during the negative half cycle, see, during the negative half cycle, there should not be any signal coming with respect to the transistor, right? So because transistor is constructed from silicon, so we are applying the sum voltage which causes one of the diode. See, either in case of positive half cycle, diode D2 is worked, in case of negative half cycle, diode D1 is worked. So that's why it provides the voltage during the period of the crossover, that is 180 to greater than, means 180 to 190, or the 0 to some 10 degree consider as. During that period they have to be given the voltage. So that's why your transistor should be worked, right? So we have problem of the crossover that should be eliminated when we have to use the this biasing, small bias voltage through the diode, right? It eliminates the whatever the problem with respect to your class AB type of class AB type of the amplifier, means it eliminates whatever the problem coming with respect to earlier configuration. This is eliminated by applying the small bias voltage with respect to your transistor through the diode. Okay, this is the thing with respect to your class AB type of the amplifier. Give me the attendance. आता लक्षात आलंय का थोडंफार तरी? प्लीज रिप्लाय द्या.
Yes.
ओके, जर लक्षात आलं नाही तर स्वतःहून सांगा. ओके, रोल नंबर 1,
Present, sir.
2, 3,
Present, sir.
4, 5,
Present, sir.
6,
Yes, sir.
7, 8, 9, 10, 11,
Yes, sir.
12, 13, 14, 15, 16, 17, 18,
Yes, sir.
19, 20, 21,
Yes, sir.
22,
Present, sir.
23, 24,
Yes, sir.
25,
Present, sir.
26, 27, 28, 29, 30,
Present, sir.
31,
Yes, sir.
32, 33,
Present, sir.
34, 35, 36, 37, 38,
Present, sir.
39, 40, 41,
Yes, sir.
42, 43,
Yes, sir.
44. ओके, ऑप्शन नंबर सांगतो. 2, 4, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 19, 20, 23, 26, 27, 28, 29, 32, 34, 35, 36, 37, 39, 40, 42, 44. ओके,
29, sir.
29 प्रेझेंट. ओके, 20 प्रेझेंट. ओके, आणखीन. ओके, स्टॉप करूया.